to this month's edition of In the Nails with me, Becky, and this month I'm joined by fellow colleague Stephanie.
Hi, I'm Stephanie. I'm the marketing manager here at Vectric, and I'm getting married soon, so I wanted to create a BEER Barrow. Becky is going to help me to create and cut the part.
So you're probably thinking, what is a BEER barrow? It's essentially a wheelbarrow that we put lots of beers in. So before we create the BEER barrow, we're actually going to look at creating a prototype. It's going to be a much smaller version of our intended BEER barrow. And so the idea is we're going to be creating a garden planter barrow. So it's a little wheelbarrow that sits in your garden as part of the garden decoration, and we put plants in it. So if that's a success, we're then going to take that, blow it up and create the BEER barrow for Stephanie's wedding day. So let's take a look at the build.
Okay then, so before I show you the software, what I have done is created a very tiny version, a little prototype that I've cut on the laser, just so I can see how everything will come together, if there's anything that I need to think about changing before I head over to the CNC to cut the larger wheelbarrow out. So we've got this part. So this is basically like a kind of frame. Okay, so these two panels slot in to the two side panels, and then that's going to sit on top of a base. Okay, so it'll form the bottom part of the wheelbarrow, the box part of the barrow. And you can see I've got a handle, so this is going to act as a strut to lever the part up. Got a hole here for a dowel to go in, so we can put a wheel in and the two will join together. And so the idea is that this box will basically sit on top of the stand or the handle, like so. And it should be something like that. So the idea is that when we have the wheel, and I don't have anything thin enough here to test the dowel kind of position, we'll just kind of sit something like that, and so it'll be levered up a little bit. Okay, so I'm happy with that. One thing that I might do is I might look at adding in slats that go from one handle to the other to give it extra structure, extra hold, so that we can basically just simply slot the box on top. Right then, so let's take a look at the software. Okay, so as you've seen at the start, I created the panels all based around this base rectangle here. And so the front and back panels are going to stand up and they're going to slot inside of the side panels. The side panels are going to be on the edge of the base, and then the front and back panels are going to sit in between the side panels, touching the right hand edge and the left hand edge of our base to create a kind of box effect. So how do I know how these panels are going to slot into the side panels? Well, let's come over to this section of the layer here, where we've got lots of different dimensions. So first off, with the front panel, I basically drew the length of that, or the width of this, based on the distance between our base part, okay, but where we've got the side panel coming in, so we must account for that material thickness, which is 0.4827 on either side of the base, to then accommodate this that would sit in the center. Okay, so in terms of the front panel or the back panel, I have a tab that I just randomly positioned roughly in the center, and so I measured the distance between the bottom of the tab and the bottom of our panel, and that is 2 inches. And so for the side panel, I've replicated that here, so you can see we've got this pocket over here, and we can see that the distance between the bottom of the panel and the bottom of the pocket is also 2 inches, which equals to this distance here. So you want to make sure that everything matches up in these sorts of slot together jobs. Now the length of the tab for our front panel is 4.009, and so I must make sure that the length of the pocket is also the exact same. Now the tab thickness here is 0.2, so I must remember that when I come to pocket out the tabs, well, sorry, not the tabs, when we pocket out the slots for the side panels, that we do that at a depth of 0.2 so that this can fit right in. Our slot thickness has to be equivalent to our material thickness, and that is pretty much it. So that's all the important dimensions that we've got there. So from there I created the kind of exploded view, and then I took the top panel and put that over here. I've got a border here, and that was just really to kind of offset the pocket holes for our slots, and so our front panels and our back panels, which is these ones here, are going to be kind of offset inside of the side panels. Drew a line in the centre here, and that's how I basically copied parts from one side over to the other using the mirror tool where we flipped about the line, so everything's symmetrical. Then I took this shape over here, so remember it's the side panel sat on top of our base plank, and then coming over to the right hand side, I basically used that to then draw around and created this handle. Okay, so it's kind of in the style of a wheelbarrow, got quite a shallow curvature in terms of the handle, and that comes over at an arc, and then with that arc I was able to basically draw a circle which is the same diameter as the dowel that I plan to use to push in through one handle into the wheel and then out to the handle on the other side. And drawing that circle, I was able to snap basically to the radius of the arc. And so that was that, and then I drew a larger circle for the wheel. You'll see here I also have these rectangles in place. Okay, so these rectangles basically represent some slats that I'm going to input, which is basically this shape here. So this shape is the same height as our rectangle base, okay, and that's basically going to act as a slat, just a support to bring the two handles together. This also enables me to basically have a base handle set up like a structure where I can interchange the actual box itself. And so here I've accounted for the material thickness of the slats that I'm going to put in terms of the height of that rectangle there. Now we all know that wheelbarrows have a strut, and it kind of levers the wheelbarrow up on a particular angle. So to do that, what I did was, if I just switch the dimensions layer off temporarily, so I basically drew a line going from the bottom of the wheel, so I snapped to the bottom node of the circle, drew a line out, so something like this. So I drew a line out, this kind of represents my floor, or the 0, and then I basically box selected everything here, select it again to put it into transform mode, select the center node there, and that will open up my rotational center, or we could call that a pivot point, which I want to rotate about the center of this circle, as this is my pivot point. And I simply raised it and then simply drew in a shape where I arced the bottom, so I had something that looked like this. So that's how I created that. So let's close out there, and then with that in place I basically welded the vectors together to create my final shapes that I needed. So if we just press F to fit that to the screen, I'm going to switch off the working layer and we're going to go to the parts basic layer. So this layer is particularly useful for yourself because the layer is for all of the parts that we require where we have no fillets, no allowances or no form of decoration here. So this really is a blank canvas for you to edit the slots according to the material thickness that you are using, edit the circle vectors according to the diameter of the dowels that you are using also. And so if we just zoom in over here, you can see I've got these rectangles that represent my slots. I have the wings which you can extend if you wanted to add more of a thickness to the tab there, and you also see that I've got these rectangle vectors that represent pockets for the slatted areas that are going to join the two handles together. Okay, so that's pretty much it. So in terms of actually cutting this out, I'll show you what I did to my versions. I'm just going to click on that to make that the active layer, and here is my kind of setup for how I created our part. Right then, so over here you will notice that we've got fillets in all of the areas that need to be filleted out, where we have corners that are basically having areas slotting into other areas. So these areas are going to have our planks, and then our tabs are going to slot in to the pockets here, which also have these fillets. And the fillets are based on the radius of the tool that I'm going to use, in which case I'm using a 1/4 inch tool, so I specified the radius of that in the fillet tool. Okay, one other thing to point out here is when we cut out slot together parts, I always like to apply negative allowances, particularly to areas such as the pockets and areas that are having things slotted into them, just so we're overcutting them slightly so that we can best fit the two parts together without it being too tight or too loose. Now, for the handles, I've actually manually added the allowances to the handles for our slat tracks here. And the reason for that is because it's only this section that I'm actually using as part of the slot together assembly. So I don't want to put a negative allowance over the entire thing, just the areas that I'm actually using to slot parts together. So here you can see what I've done is I have basically created another rectangle that sits on top of the original, where I've basically offset it outwards by, I believe it was 0.005. So if we take that and offset that outwards by 0.005 offset, we can see that that's created that. So that was the allowance that I used. So close out there, and so what I did with that, so you can use this as an example. Basically created another copy over here where I welded, where I used the snip tool to get rid of those areas that I didn't need, so then I was able to fillet our part. Okay, so that's pretty much it in terms of the vectors. I also have some decoration here, which is using the vector texture tool in order for us to create a faux wood grain effect that I'd use with a V-bit tool and the texture toolpath, just to apply some decoration to really spruce up that boring MDF. And we'll come back to this later on. Now the two side panels I've actually kept separate here, and the reason for that is because I am cutting this as part of a two-sided operation, and I don't want to put the whole sheet in and then flip the whole sheet, so I've basically kept this separate, and we'll look at that file shortly. So going over to the toolpath, so I'll just show you some of the settings that we've got in there. Okay, so let's take a look at this where we tile the windows horizontally. So I'm not going to discuss the texture or the profile border. I'm going to come to that in a separate example where we're looking at the side panels. So for everything else we have profile cutout, so this is using a simple cutout pass, okay, cutting on the outside, add ramps just so that we keep the tool away from the very edge of the tool as it plunges in. Then we have profile allowances, and here if we take a look at the toolpath itself, so it's basically a profile going on the inside of all of the vectors that represent the dowel. Okay, so we've measured out the dowel diameter, and I've put that as a circle in the software. And you'll see here we've got an offset of negative 0.005. Now in my experience this is a good value to use for slot together projects, either that or 0.01. Those are the two values I usually switch between depending on material that I'm using, and so the idea here is if I just take that and then put this into a solid preview, is it's basically going to overcut it. So everywhere that is shaded purple is basically what's going to be cut away, and you can see it's just doing that as a little overcut by the value that I put in there. And so when I come to actually cut this out in the machine, I'm actually going to take my dowel and put it in just to ensure that that is a correct value, and if it doesn't go in then I'll just overcut it ever so slightly again until I got the an allowance that seemed suitable. Now for the wheels, I'm applying a larger allowance, which this time is negative 0.01, and so the idea here is we're just making that a little bit bigger because I want to ensure that this is going to rotate freely around. Now with it talking about the wheel, with it rotating around the dowel, how am I going to stop this from moving left to right? Well, that's what these are for. So these are basically kind of stoppers that are going to go either side of the wheel with a negative allowance, same as our handle holes for the dowel to go in. So the dowel will go in through here, in through a stopper, in through a wheel, in through a stopper, and then to the other side of the other handle. And this should basically keep that wheel in the centre of the dowel so it's straight. Okay, so that is pretty much it in terms of everything that you need to create the Mini Planter Barrow. So now we're going to take a look at the side panels. Okay, so Planter Barrow side panels, Mum's Garden. Okay, so this is a two-sided file. So at the moment we're looking at the top side. You can see I've got the slot holes for the front and back panels to slot into. I've got this asymmetrical dowel set up here, so that's all a part of the two-sided flip process. There's lots of videos on this method, so if you've not done two-sided machining before, then head over to the tutorial browser where you can search for two-sided machining, and I discuss this method in most of those videos. Right, and so on the bottom side you can see we've got the word Mum's Garden, EST 1966 there, and we have this faux grain texture. So this texture was created using the vector texture tool, using the settings that I've got in here, and that simply enabled me to create all of these lines that I'm now able to use as part of the texture toolpath to create that faux wood grain effect. Okay, so if you want to change the text, just simply select the text and just ungroup those objects, whereby you can then select one of the items, use the text option, and then simply put in Dad's or whatever it is that you want to create. Okay, so you can do that. I'm just going to undo that, and with all of those vectors, let's take a look at the toolpaths. Okay, so we've got dowels here as part of our two-sided machining. I'm not going to look at these, I'm just interested in the actual texture itself. So looking at that, using the texture toolpath. Why? Because this will enable me to create variation in the depths of cut along the vectors, whereby I specify a maximum cut and a minimum cut depth here. And if you've not yet used this toolpath, then simply head over to the tutorial browser where you can search for videos that use the texture toolpath and discuss that at much length. Okay, so we're going to have a maximum cut depth of 0.1, a minimum of 0.055. Simply hit calculate. What will happen is using a 90-degree V-bit, it will create something that looks like this. Okay. And then for the profile of the text, simply just going around the outside of the text with the same tool at the same cut depth, which is 0.1. Okay, and let's just bring in that text out, giving it a nice beveled edge. And then we've got a border here. That's just finishing the edge off there real nice. So when we go ahead and preview all the sides, you can see how the part looks. So on the top side, we've got the slots. Okay, the pocket depth here is 0.2. Remember, I showed you that the front and back panels for the box, the tab was 0.2 wide, so making this a 0.2 depth. And then on the front side, as you've seen there, we've got this nice texture with the beveled text, and you can change this to whatever text that you like. So let's take a look at cutting the parts out.
So the paint is now dry, and that is our Garden Planter Barrow complete. So we've got this beautiful faux wood grain effect here. We've got the text for the Mum's Garden. It moves, it stands up nice, it's a nice size, so everything's perfect there. So we're going to now take our file, we're just going to tweak it, make it much bigger to cut the BEER Barrow. So we'll go ahead and take a look at the build for that. Okay, so we're back in the labs. We've got our sheet of MDF. We've completely covered it in double-sided carpet tape. We've screwed down each corner of the sheet into our spoil board, so we've got maximum hold down. So now we're going to set up the machine, and then we're going to run the toolpath for our first sheet.
step is testing the fit of the dowel at the allowances that we've set. This way, if we need to overcut it a little bit more so it can fit in, we can whilst the material is still on the machine. So again, like earlier, we're just checking the fit here of the front and back panels in the pockets of the side panels before we flip the material over to cut the wood grain texture.
That completes the build of the 2 wheelbarrows. So if you fancy having a go at creating your own garden planter barrow, then simply head over to your VCarve account where you can download the project files from there. And if you like this video, give us a thumbs up. And if you've not yet subscribed to our channel, then please hit the subscribe button for updates on the latest videos that we will be releasing. So thank you for watching and happy making!